All right. Activity 3.3, no place like home. Suppose this graph summarizes your day. The x-axis of this graph represents time in minutes from 12 p.m., and the y-axis represents your distance from home in blocks. Locations north of your house are positive, and locations south of your house are negative. A point at the origin represents you being home at 12 p.m. Okay, so you're home at 12 p.m. right there. Okay, describe the meaning of each of the four labeled points. So the first one we have is -2, -4. So I start at the origin, -2, -4 is this point right here. So that point right here is 2 hours ago at 10 a.m. I was 4 blocks south of my house. Okay. The next one is 0, 0. And so that's point B right here. This is point A. This is point B. At 12 p.m., I was at home. Okay. The next point here is 4, 2. Go to 4, go to 2, that's point C. At 4 p.m., I was 2 blocks north of my house. And the last point on here is 8, 4. Over 8, go up 4. So that's point D. And so that's saying at 8 p.m., I was 4 blocks north of my house. Okay. So the coordinate plane here is showing time versus how far north or south of my house I am. Number 2, Adrian and Sierra are discussing how the graph should look before x equals -4, x equals -6, and after x equals 10. Adrian thinks he should draw arrows to indicate that the graph continues to the left and right respectively. Sierra disagrees and thinks they should draw segments back to the x-axis. Who is correct? Well, I think Sierra is correct. Okay. You don't have enough information to know exactly what happened after 10 p.m. or before 6 a.m. it is likely that you would have started at home, would have started and ended at home, which is at the x-axis. So the line probably would have went back up to the x-axis right along here at the beginning of the day and at the end of the day. Okay. So we're using coordinate planes to graph different things. And so this is an example that it's not always going to be a straight line, and it's not always going to continue, depending on the situation. All right, let's consider another graph. So we have this one right here, and here's the line, and then it goes right back to there. This is the x-axis. This is the y-axis. So everything in here is in quadrant number 1. It says write a possible scenario for this graph. Be sure to specify the units and the meaning of the origin for your scenario. And so we could have a whole bunch of answers here, but I'm going to give you a scenario. So let's say that this graph describes the amount of money in a parking meter before and after it is emptied. The quantities that change are the time in hours and the amount of money. So if I'm thinking about this, on the x-axis, this would be time. And then in the y-axis, this would be money. And so here you can see how there's more and more money, and then no one's parking, and then someone empties the quarters out of the parking meter. Okay. So that's just one scenario. There's a multitude, but just the idea of trying to come up with the scenario that goes with the graph. Okay. There's another scenario. Natasha and her family took a 3-day trip to her grandmother's house. On the first day, they drove 300 miles. On the second day, they drove 350 miles. On the third day, they drove the remaining 200 miles. Create a graph to represent Natasha's family trip. Be sure to label your axes with quantities and units, and label specific points that highlight the trip. So along here at the bottom is the x-axis, and I would say that this would be the number of days. Notice that I'm trying to put the same amount of time after each number of days. Along the y-axis right here, it would be the distance traveled. And then that would be in miles. Again, trying to make sure I have like an even interval. And on the first day, they drove 300 miles, so this would be my first point. On the second day, they drove 350 miles, so that would be 350 more. On the third day, they drove the 200 miles, so 1, 2. Okay. And so this graph would look like this. Okay, so we're practicing thinking of a situation, thinking about what it would look like on a graph, and then making a graph that goes with that situation. All right, this next one for number 5. Nadja is coordinating the neighborhood spring fling. She asks Matthew to blow up balloons for the event. The graphs shown represent his efforts. So graph 1, we have the time in seconds. Along here, we have volume of air in the balloon, cubic feet. So how much air has gone into the balloon? Because it goes up and it goes down. Okay, so here's graph 2. And so Matthew is blowing up this balloon in this amount of time. Then the air that's going in is how much, and then it steadies off. Then for graph 3, Matthew's blowing it up in this amount of time. This is the volume of air. And then this one, the time, and then this is the volume of air. Okay. Analyze each graph shown and then answer each question. What quantity is represented on the x-axis in each graph? Well, the x-axis represents the amount of time to blow up each balloon. Okay. What quantity is represented by the y-axis in each graph? The y-axis represents the volume of air in each balloon. C. Which quantity is independent quantity and which is the dependent quantity? The independent quantity is the amount of time and the dependent quantity is the amount of air in each balloon. And for me to know that, I say one thing. Which one makes more sense here? The amount of air depends on how much time you took to blow up the balloon, or the amount of time depends on how much air is in the balloon. And the first one makes more sense, and that's how I know which one's the independent and which one's the dependent quantity. The air in the balloon depends on how long you were blowing up the balloon. Okay. Now we just need to we have to match the description with the appropriate graph. Okay. In A, Matthew blows air into a balloon at a steady rate, then ties it off when it's full. Okay, so if I look, this one gets full and then it's empty. This one gets full, but it kind of gets full at a uneven pace, and then it's full, then it's tied off. This one it gets full and goes bloop. Okay. And so if I'm looking at this, steady rate and then ties it off is going to be graph 2. Description 2, or B, Matthew blows air into a balloon and then the balloon pops. Well, if I look at this one does not pop, this one does not pop. This one's empty, but it doesn't pop. It goes, graph 4 blows it all the way up, and then it pops. So that was going to be graph 4. It's a sad day for blowing up a balloon. C, Matthew blows air into a balloon and then lets the air out. Well, we already chose this one. We already chose this one. This one, you put the air in and then it blows out. And so that's graph 1. Matthew blows air into a balloon slowly. As the balloon stretches out, he's able to blow more air into the balloon. He then ties off the balloon when it is full. So this is where you blow it in slowly, then you're able to blow in more air, and then you tie it off at the end. So that is graph 3. Okay. And so we are looking at graphs for different situations in this particular section. And we're trying to understand what those graphs mean. Okay. And that was lesson 3.3.